This is 4.3, day 2. We're still going to be factoring, but now we're going to look at the difference of two squares in perfect square trinomials. I want to start off by looking at the difference of two squares. So it gives the example of x squared minus 4. Now, can you see that x squared and 4 are both square numbers? Because we could take x times x to give us x squared, and we could take 2 times 2 to give us 4. So really, another way that we could write this is x squared minus 2 squared, because 2 squared is 4. Now hopefully you can really tell that is the difference of two squares. But this is different than the trinomials that we were factoring because we don't have an x term here, right? We just have an x squared and a constant with no x in the middle. That means our x term must have canceled out when we added them together. So for example, let's see what happens when I FOIL my red binomials over here. I'll get x squared minus 6x plus 6x minus 36. And when I simplify, my x terms are going to cancel and I get x squared minus 36. So this would also be the difference of two squares, right? Because I have x squared minus 6 squared. So going back to our original example, how would you suppose that we could factor x squared minus 4? Now we know we have x's, and using the red example over there, I noticed that 6 and negative 6 are in my two binomials, and I also have a 6 squared here. So same thing. Up here I had a 2 squared. That means I'm going to have a positive 2 and a negative 2 in my binomials. So let's check our answer. If I FOIL this out, do I get the same thing I started with? And the answer is yes. So we factored correctly. Now looking at perfect square trinomial, there's two different forms we would have. The only difference between them is a positive and a negative sign. I think it's helpful to look at an example. So the one they give is x squared plus 6x plus 9, and we want to try to factor this. So remember that we need two values that when multiplied give us 9 and when added give us 6. So that value would be 3 and 3. So when we go and we write our binomials, we can get x plus 3 and x plus 3. This can be simplified even further to x plus 3 squared. And I think that is way more helpful than the pattern that the book gives you. I think that can be confusing to some people. So I just take my perfect square trinomial and factor it like normal and then simplify it to a squared binomial. Let's look at the other example they give. So it's x squared minus 4x plus 4. And so what two values when multiplied give us 4 and when added give us negative 4? Well, those two values are negative 2 and negative 2. So I'm going to have x minus 2 and x minus 2, which can be written as x minus 2 squared, right? Because I'm taking x minus 2 times itself, so we get x minus 2 squared. Okay, here's some more examples. The directions say to factor, so we have an x squared minus 49 for the first one. Well, what do we notice about 49? 49 is a square number, right? 7 times 7 gives us 49. That means when we factor into two binomials, we're going to get x minus 7 and x plus 7. And you could FOIL this out to check your answer, but I'm going to go on to example B. And it doesn't look like the difference of two squares form, so I'm going to factor it like normal. What two values when multiplied gives me 36 and added together gives me 12? And that's going to be 6 and 6. So I'll have x plus 6 and x plus 6. And simplified gives me x plus 6 squared. So in this bottom example, do we have the difference of two squares? No, we don't. Remember, we have this middle term here with an x, so we don't have difference of two squares. But maybe we have a perfect square trinomial, and we want to factor it. So we could list out all the factors of 169, or we have a hunch that it might be a perfect square trinomial, so in your calculator you might want to punch in the square root of 169 and you'll get 13. So we know 169 is a square number. That means 13 times 13 gives us 169. Well, what if we added 13 and 13? That's going to give us 26, and that's the middle number that we want. So that tells me that we're going to have x minus 13 and x minus 13, right? Because we want a negative 26 and a positive 169. And simplifying this further, that's going to give us x minus 13 squared. So yep, it was a perfect square trinomial. Now, I would like for you to try and factor these expressions on your own. And hopefully you were able to get the right answer. Alright, there's a lot of words on this slide, but you don't need to write down anything unless I highlight it. So the top part is basically saying what we already know is that a quadratic equation can be written in standard form. The new part is that the solutions of a quadratic equation are called the roots. So if we have a quadratic in standard form and we let y equal 0, and we can factor that quadratic into two binomials, then we can solve for x, and we're going to get two different x values, and those are the roots. In other words, those are the solutions. So the zero product property, is an important property that we use to help us find the roots. So what it's saying in words is that the product of two expressions is 0, then one or both of the expressions equal 0. So it's what we had up here. We had this times this, that's the product of two expressions, right? Here's expression 1, here's expression 2. Product means multiplication. Is 0, so equals 0. Then one or both of the expressions equal 0. So either this has to be 0, and if that's not 0, then this has to be 0. So basically it's just a fancy way of saying that if you multiply two things together and you get 0, then one of those two things had to have been 0, because anything multiplied by 0 gives you 0. So for example, let's say if I factored out and I got x plus 5 and x plus 2. And I wanted to find the solutions. So this means either x plus 5 has to be 0, or x plus 2 has to be 0. So if x plus 5 is going to be 0, then x needs to be negative 5. But if x plus 2 is going to be 0, then x is going to be negative 2. So I've just found my roots. Either x equals negative 5 or x equals negative 2. So we need to find the roots in this example, and the first step would be to factor. So what two numbers multiplied give us negative 36, and when we add them we get negative 5? Well, first I'm going to look at my factors of 36. So I have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Keep in mind that we want a negative 36, so one of our pairs has to be negative number, and we want negative 5. So I'm thinking it's going to be this pair since there is a difference of 5 between 4 and 9. So now I need to decide, is the 4 negative or is the 9 negative? Well, I want the 9 to be negative because a negative 9 plus 4 gives me negative 5. So now I know I'll have x minus 9 and x plus 4. So now I'm going to use the zero product property to find the roots. The zero product property says that either x minus 9 has to be 0 or x plus 4 has to be 0. So I'm going to solve each of them separately. And I've found my roots to be negative 4 and 9. So the correct answer is C. Okay, I want you to try this example on your own. The directions say solve the equation. And remember that when we solve, that's going to give us the solution, and the solution is our roots. So basically this is asking you to find the roots of the equation. So pause the video and good luck. Hopefully you found the roots to be 7 and negative 6. So that's the end of this video. Come to class prepared to work out more examples and ask questions.